Lanthanides comprise the 15 elements from lanthanum, La, atomic number 57, to lutetium, Lu, atomic number 71. They are located in the first row of the F block, inner transition elements. They belong to period 6 of the periodic table. All lanthanides are metals. They are often called rare earths, though most are not actually rare in the Earth's crust. Cerium, Ce, is the most abundant lanthanide. Promethium, Pm, is the only synthetic and radioactive lanthanide. They are chemically very similar to one another, making separation difficult. Their electronic configuration generally involves the filling of the 4F subshell. They are silvery white, soft metals. They can be cut with a knife, especially the lighter ones. They have high melting and boiling points. Their density increases with increasing atomic number. They are good conductors of heat and electricity. They exhibit a bright metallic luster when freshly cut. They tarnish quickly when exposed to air. They are highly malleable and ductile. Most lanthanides are paramagnetic due to unpaired electrons in the 4F orbitals. Lutetium and lanthanum are diamagnetic, no unpaired F electrons. They have high coordination numbers, often ranging from 7 to 12. The lanthanide contraction. The atomic and ionic radii decrease steadily from La to Lu. This phenomenon is known as the lanthanide contraction. It is caused by poor shielding of the nucleus by 4F electrons. As atomic number increases, the effective nuclear charge increases, pulling electrons closer. Lanthanide contraction makes ZR and HF have nearly identical sizes. It accounts for the high density of elements in the third transition series, 5D. It affects the basicity of lanthanide oxides. Post-lanthanide elements are heavily influenced by this size reduction. It makes the separation of these elements by ion exchange possible. The most stable and common oxidation state is +3. Some elements also show +2 or +4 states. They are highly electropositive. They react slowly with cold water and rapidly with hot water to release hydrogen gas. They burn easily in air to form oxides. They react with halogens to form trihalides. They react with nitrogen to form nitrides. They react with sulfur to form sulfides. They react with acids to liberate hydrogen gas. Their oxides and hydroxides are basic in nature. The basicity decreases from lanthanum hydroxide to lutetium hydroxide due to the decrease in ionic size. They form complexes primarily with oxygen donor ligands. They have a lower tendency to form complexes compared to transition metals, D block. Their compounds are generally ionic. Color and spectra. Many lanthanide ions are colored in both solid and aqueous states. Color is due to FF transitions. These transitions are Laporte forbidden, resulting in pale colors. Lanthanum +3 and cerium +4 are colorless, empty 4F. Lutetium +3 and ytterbium +2 are colorless, filled 4F. The absorption bands in lanthanide spectra are very sharp, narrow. This sharpness is due to the 4F orbitals being deeply buried and shielded by 5s and 5p electrons. The spectra are largely independent of the environment, ligands. Many lanthanides exhibit strong fluorescence and phosphorescence. All trivalent ions except lanthanum +3 and lutetium +3 show paramagnetism. Magnetic moments arise from both spin and orbital motion of electrons. Orbital contribution is significant because 4F electrons are well shielded. Gadolinium, Gd, is ferromagnetic at low temperatures. Dysprosium and holmium have the highest magnetic moments. Lanthanides always occur together in minerals like monazite sand. Ion exchange chromatography is the most effective method for separation. It relies on the slight difference in hydrated ionic radii. Solvent extraction is used for large-scale industrial separation. Fractional crystallization was historically used, but is very slow. Valence change methods can separate SU and EU by shifting their oxidation states. Specific elements and facts. Lanthanum, La, used in camera lenses for high refractive index. Cerium, C, used in flint for lighters. Praseodymium, Pr, used in yellow glass, didymium glass. Neodymium, Nd, used to make the world's strongest permanent magnets, NdFeB. Promethium, Pm, used in luminous paint and nuclear batteries. Samarium, Sm, used in SMCO magnets, which are stable at high temperatures. Europium, EU, vital for red phosphors in LED and CRT screens. Gadolinium, GD, used as a contrast agent in MRI scans. Terbium, TB, used in green phosphors and magneto-optic recording. Dysprosium, DY, used in nuclear reactor control rods. Holmium, HO, has the highest magnetic strength of any element. Erbium, ER, used in fiber optic amplifiers, EDFAs. Thulium, TM, used as a radiation source in portable X-ray machines. Ytterbium, YB, used in portable X-ray machines and atomic clocks. Lutetium, LU, used in PET scan detectors. Mischmetal, an alloy of Su, La, and D, and Fe, is used in pyrotechnics. They are used as catalysts in petroleum cracking. Lanthanide oxides are used to polish precision glass. They are used in the manufacture of high-strength alloys. Used in carbon arc lighting for studio and projection lights. They are used in lasers, e.g., ND, YG lasers. Used in superconducting materials. Lanthanide chelates are used as NMR shift reagents. They are used in the doped fibers of long-distance telecommunications. Used in night vision goggles and rangefinders. Used in nuclear medicine for cancer treatments. They are generally non-toxic, but should be handled with care as dust. Most are found in the mineral bastnasite. The extraction process is chemically intensive due to their similarity. They are often grouped with scandium, Sc, and yttrium, Y, as rare earth elements. They have very similar electronegativity values, around 1.1 to 1.2. Their ionization energies are relatively low. EU and YB show anomalous physical properties like lower density due to half-filled/filled F shells. They are essential for the green revolution, wind turbines, EV motors. China currently dominates the global production of lanthanides. Despite the name, thulium is rarer than gold, yet still considered a rare earth.